So I want to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and today, as you can see from the slide, we're discussing designing with sheet metal in Onshape. And the goal today is really to get you familiar with the sheet metal tools in Onshape and why they're different than some of the older CAD systems that exist out there. Some of the things that we've tried to solve with sheet metal design with our implementation of simultaneous sheet metal and Onshape. Now, as I always say with these webinars, I really encourage you to ask any questions that you'd like. There's a question section in the GoToWebinar control panel. Feel free to ask any question that you'd like, and I'll do my best to stop and answer the questions as we go through today's webinar. But the goal today really is to get you familiar with Onshape sheet metal tools and why they're different, why they're better than what you may have used in past CAD systems. The agenda today is pretty straightforward. We're going to start with a simple introduction to sheet metal design. So if you've never designed a sheet metal part in 3D, just going to discuss what's different about sheet metal design in general, not specific to Onshape, but just in general. Then we're going to get into how Onshape's simultaneous sheet metal tools are different than what you may have used in the past, and they have a lot of advantages. I'm going to go over some of those advantages in just a bit. Things like the ability to see everything update in real time has a real big advantage when we talk about, the old CAD system of the past where it was a constant back and forth. So I will walk you through a few examples of creating sheet metal parts. I'll show you the 3 ways that we have to create sheet metal parts and all the various tools that we have to manipulate them and flanges and so on. But I do want to walk through and spend a bit of time on, what makes Onshape sheet metal tools different. And I will show you some of the strength of the capabilities of Onshape sheet metal tools as we go through this. Now, as with all webinars, again, we really encourage you to ask any questions that you'd like. We'd like to make these as interactive as possible. There's a question section in the GoToWebinar control panel. Again, type in anything that you'd like, and I'll do my best to answer them. So we're going to start with a simple introduction into what is sheet metal design. So if you've never designed a 3D sheet metal part, of course, what is sheet metal design? You're designing parts in sheet metal. But sheet metal has some unique rules that apply that don't necessarily apply to really anything else. If you think about sheet metal parts, they must have uniform thickness, right? Sheet metal is always the same thickness. And they have this unique need to unfold. Right? Unfolding sheet metal parts is a critical part of it. Of course, we start with the flat and we bend the sheet metal into shape. And those are the 2 unique aspects of sheet metal that you really have to design around. You have to have tools for. And of course, in Onshape, we have all of those sheet metal tools, and we've done them in a really unique way. I'll go over those details in just a bit. But again, uniform thickness, need to unfold, those are things that if you're designing sheet metal parts in 3D, those are must-haves. And all professional level CAD systems have this to one degree or another. They have these kinds of capabilities. We'll go over this in just a bit. The last thing I want to mention about this is, it has the rules. It has to be able to unfold. It has the default bend radius, default corner relief. You can establish all of these default sheet metal specific settings as part of your design. And it just makes the sheet metal design process very easy. So in short, sheet metal design is, of course, about building 3D sheet metal models that unfold and have uniform thickness. The sheet metal tools that are available also make things simpler, like default bend radiuses and corner reliefs, just to make the process smooth. Now, what I want to spend a moment on is the way this has been done in the past, and it's one of the key problems that we set out to solve with Onshape's sheet metal tools. If you look at the way that old CAD systems did sheet metal, it was often a state that you would go between. So the flat model and the folded model would be these switches that you would turn on and off. Oftentimes there were even features in the feature list that you would unsuppress and suppress. And so, it always led to this back and forth workflow where if you imagine you're building your sheet metal part and, as you're building it, you really don't know what the flat pattern looks like. And you're kind of selecting edges and faces and getting all these, odd combinations. You don't really see what the end result of the flat pattern is until you accept the feature and then click, a flatten button or a flattened feature or a checkbox, or you toggle this on-off state. And what this leads to is, a constant back and forth, because inevitably, something will not be right in the flat pattern. The flat pattern in these sheet metal parts is as important as the folded model. It has to be, technically possible to make this, which means it needs to be able to unfold in a certain way so that it can be bent in a certain way. And, going back and forth between the flat pattern and the folded model was always a tedious workflow. Again, the reason is you may have several edges that you're not sure how should unfold to get a properly, proper flat pattern, and you may be doing this trial and error process of you editing a feature, accepting it, hit flatten, look at it, go back, edit the feature, accept it, hit flatten. So it's just this loop that you have to constantly go through to design sheet metal parts. And so inevitably, when you talk to someone that's done this kind of sheet metal design, they're just constantly hitting flatten, after every single change. The fear being, if they make several changes to their sheet metal part and then flatten, they'll realize that they have to go all the way back, to the beginning, essentially. So it is always led to a tedious back and forth workflow. If you have to go between or toggle on and off your flat and folded model, it really it really is a slow process where you may not understand the implications of the feature until after you accept it, flatten it, and look what it, the end result is. The other thing I would say about these older CAD systems is there's very little to no consideration for manufacturing. So when you think of sheet metal, manufacturing is a very critical element in the process. And, if I shared my, let's say that I had internally even, I shared my design with my manufacturing team internally in my company, and I shared my SolidWorks part. And they realize, they need to change a bend radius because they don't have the right die or whatever the reason may be. They have to go find the feature in the feature list. They have to hunt through the features in the feature list, find the appropriate bend, change the bend radius on that one bend. So it's essentially forcing them to kind of hunt through something else that someone else designed, or they ask the engineer that designed it to change the radius. So there's never really been this consideration of how do we incorporate those that manufacture this into the design so that those important details like the correct bend radius that's applied to the part, or whether it's a bend or a rip, that's a common thing to change between. All of those details are often changed based on manufacturing decisions. And, that constant back and forth always led to, a lot of headaches. So again, the consideration for the manufacturer in the sheet metal design is something that's very much been lacking. Basically no consideration for the manufacturing and that, data, that important data, things like bend radius, things like the bend order. As I mentioned before, things like whether it's a rip or a bend. Those are all important considerations that often get changed based on decisions by manufacturing. So these are all things that I would point out as flaws in older CAD systems and their implementation of sheet metal. Again, just the back and forth nature caused a lot of tedious, trial and error, and no consideration whatsoever for, the manufacturer in the design process. So these are things that we set out to solve with Onshape's simultaneous sheet metal tools, and that's what I want to get into here today. So what's different about how Onshape has done sheet metal design? And the biggest thing that I would stress, if you had to take one thing away from this webinar, it would be that in Onshape, when you design sheet metal parts, you get 3 simultaneous views of your sheet metal parts at all times. Even as you're creating features, even as you're experimenting with the design, you can look at the flat pattern, the folded model, and a table with all the bend information, detailed, rip information, and so on, and all of it updates simultaneously. Now, this is an example where we've used a cloud architecture to make a core CAD feature, in this case sheet metal, better. So rather than going back and forth between a folded and flat view of your sheet metal parts, you can just have both open at the same time. And if you make a change in one, the other instantly updates. So this is a real advantage when we talk about sheet metal because, as mentioned before, the flat pattern in many situations is equally as important to the folded model, and the ability to actually manufacture it is key. So again, the ability to see that flat pattern and instantly see when you make a change in the folded model, it instantly updates in the flat pattern. You'll know right away if you have any kind of issues. The other unique thing that I always like to mention about our sheet metal tools is if you have any kind of flat pattern collisions, let's say that you have two flanges that are overlapping in my flat, I will instantly get a little notification in Onshape. As I click that edge, I don't even have to go to the point of accepting the feature. I'll see it even as I'm selecting edges. So as I mentioned before, it really informs you as to the state of the flat pattern at all times, not just when you click a certain button. And that's the one thing that I would stress about our sheet metal tools. And I think it allows you to get through that experimentation stage very quickly without that tedious back and forth. So as I mentioned before, the key that I would stress is you have a folded view of your model, of your sheet metal part, a flat view of your sheet metal part, and also a table with all of the details of your sheet metal part. And they all update instantly to any changes in any one of them, right? So the key thing, again, no more trial and error, clicking on edges, looking in the flat pattern and going back and forth just to see, if the flat pattern is something that you're happy with. So that's the key thing I would stress. There's lots of little things that I could go into detail on about how we've done, the implementation of individual features and so on. But on a high level, the sheet metal design tools that we give you have, we're not just an incremental improvement to sheet metal design over old CAD systems. They're a fundamental shift, right? The ability to see all those things update in real time makes you a much more efficient sheet metal designer. All right, so let's get into it. Now, as I mentioned before, what I would like to do today is walk you through building a few simple sheet metal parts and walk you through kind of the basics of starting your first sheet metal part, looking at that flat view and table view and going through all the details of using sheet metal and Onshape. And I want to start with the three ways that we have to start a sheet metal part. So it's important to remember we have three different techniques that you can use for creating a sheet metal part. And it all depends on the scenario. I'm going to show you an example of all three in just a moment. The first and one of the most common is converting a solid. So oftentimes, especially in the scenarios of like designing enclosures, sheet metal enclosures, I might model a solid, block, let's say, or, a shape to reflect that enclosure. Well, you can take that solid shape and convert that into a sheet metal part. That's one of the first techniques. The second technique is extruding an open profile. I think this is one of the most common in past CAD systems, old CAD systems, and that's just selecting, sketch geometry, for instance, and referencing that for your sheet metal part. Again, I'll show you an example of that. And then finally, we have the ability to thicken a face. And that just means you select faces, it thickens them, and you get a sheet metal part out of the end result. So those are the three different ways that we have for creating sheet metal parts. And I want to stress these are not all of our sheet metal tools. This is just one command in our sheet metal tool set. But these are the three ways that we have to get started with a sheet metal part. All right, so let's get into it. Now, as I mentioned earlier, and I want to stress again, I really encourage you to ask any questions that you'd like. There's a question section in the GoToWebinar control panel. Type in anything you'd like, and I'll do my best to stop and answer the questions as we go through sheet metal here. All right, so I'm going to keep this basic, and we are going to start simple. And what I'd like to do is walk you through an example of building, a simple sheet metal enclosure and walk you through the three ways that we have to create sheet metal parts. And we're going to start with the sheet metal model command. So in the Part Studio toolbar, you'll find the sheet metal model command. I'll click this, and as I mentioned before, you have three options for creating a sheet metal part. You have convert, extrude, and thicken. So they're all a part of this one sheet metal model command. And so for every new sheet metal part that you create, you will go to this command and choose the technique that you'd like for creating your sheet metal model. Now, as I mentioned before, you can take a solid part and convert it into sheet metal. So in my example, I have a solid block here that kind of reflects the enclosure shape that I want. And so I'm going to leave it set to convert, and I'm going to click on this part that I want to convert, right? So now I have essentially an offset sheet for every face in this part that I've selected. And I can go in and define faces to exclude. In this case, we'll exclude these 3 faces. And then we'll define edges that are going to be bins. So in my case, you can see if I zoom in here, these 2 sheets are not joined, but they should be. This should be a bend. So I'll select that edge, and it will convert it to a bend. Right? Same thing over here. Select this edge, converts it to a bend, rotate the model around, select the back edge here, and again, converts it to a bend. Notice I automatically get corner reliefs. In this situation, we have a corner being created by these 2 bends, and I automatically get that corner relief as such. So that's converting a sheet metal part. You can define what part do you want to convert, what are any faces that you want to exclude from the sheet metal part that you're creating, and then what are your edges to bend. Right? So again, very simple process. I can hit the green, check OK, and accept. But there are a few final things I want to mention about this. I mentioned before, the sheet metal tools that you create, the sheet metal parts that you create using Onshape sheet metal tools will unfold, will follow uniform, wall thickness, all the rules that you need. And you establish a lot of those, default bin radius, corner relief, all those settings in this sheet metal model command. So in the bottom half of this dialog, you have, here's your sheet metal thickness, here's your bin radius, K factor, very important for calculating stretch, rolled K factor for rolled parts. We have minimal gap settings, default corner relief types, right? Default bin relief types, and then the individual values for those bin reliefs. So here's where I'm establishing all of my default, settings for thickness and so on. All right, so a few questions that I see have popped up. Can you edit, modify the flat pattern directly? There is some ability, and we are working on this ability even more. There is some things you can interact with in terms of the flat pattern, but not everything. And so I would stress again that the majority of the work is going to be done in the folded state, while the flat will automatically update. Now, we are working on more functionality in the flat view, and I'll explain what I mean for those that don't know the flat view just yet. I have a table from my manufacturing bin. Can Onshape integrate these specific values? No, not as of today. So the question, I have a table from my manufacturer with radius, K factor settings, and all these specific values for gauges and materials and so on. Can we integrate with these values? And the answer is no, not today. Today, you would literally type in those values as you start the sheet metal part. Again, something that we are working on a cleaner solution to in the future, but today would involve punching in the values as you initially create that sheet metal part. Is it possible in Onshape to make a more simple corner and relieve the corner relief completely? I know you could make the relief smaller, but can you remove it completely as you can with SolidWorks? I believe that would be the closed corner type. Have you tried closed corner type? Forgive me if I'm misunderstanding the question. I think that would remove the corner relief completely. Let's try. So that is the closed corner relief option. Question, can we specify bend allowance instead of K factor? No, not as of today. So it's strictly K factor as of today. All right, so that is closed corners, I believe. Yeah, if that isn't what you're looking for, please let us know. Use the feedback tool and let us know. That is the closest thing that I could think of. All right, so that is creating my first, simple sheet metal part. Again, as you go through that sheet metal model command, you specify all the details of, default bin radius, K factor, and so on. I hit the green, check OK, and now I have my first sheet metal part. Now notice sheet metal model is a feature in the feature list. So if I want to change a default, bin radius setting or corner relief setting or any of those types of things, all I have to do is right click edit, no different than any other feature. So that's creating my initial sheet metal model and using the convert option to do so. Now, the question inevitably becomes, well, where's the flat? How do I view the flat? You mentioned before, you can see it update simultaneously. The moment that you have a sheet metal feature, you can see a little icon on the right for sheet metal, table, and flat view. And you can even do this as you're creating and building that feature. But if I left click here, right, I can bring out the flat view. And I can leave this out if I choose to. So if I decided to make changes to this model, I could easily go in and do that and look at this update live, right? So for instance, if I were to go in and create something as simple as a flange, left click an edge, and you would see, right, that update live. And if I change the distance here, let's change it to 50, right, it updates in both views instantly. The biggest reason that I specify this, that I point this out, is that you will see those collisions instantly. So if you have a flange that collides with another flange, it will automatically tell you. You'll get a little notification, a collision in the sheet metal part. In this case, the flanges work fine because we automatically miter those corners. But you can see as I add these flanges to my sheet metal design, they instantly update in that flat view. So I hit the green check OK. Now we have a few flanges added just by left clicking. But the key thing I would stress here is that flat view is a simultaneous updating view. Right? So you have your folded model, your flat model, and you can look at them both at the same exact time. Now, it's not the only element of this. As I mentioned before, there are 3 things that update when you edit and you create parts in sheet metal. And the third thing is the table view. The table view is the top half of this flyout, and it gives you a breakdown of all the details of your sheet metal parts. So default radius, right? You can see if I go through, if I mouse over these joints in the table, they highlight in both the folded model and the flat view. If I wanted to change a default bin radius, I can double click here and change a radius, and it updates it in the feature. The important thing I would stress here is, let's say that, for instance, in the example I gave you earlier, I share this with my manufacturer internally. Assuming they have the appropriate permissions, the modified permissions, they can change a bin radius to something that matches their tooling, for instance, without having to hunt through the feature list. Right? Sometimes this feature list can get really long, and having someone who didn't design the part go through that feature list and find the bin radius they're trying to modify and then edit the feature, do that is just not practical, and it's a cumbersome workflow. So the idea here is every single bin is listed in a table, independent of the features. Now, if I change a value here, it will, of course, update the features and vice versa, right? But I don't have to hunt through the features to find those things. And it's not just, the radius values and the bins accordingly. It's also things like rip to bend. Often, you need to change a rip to a bend or vice versa in order for the part to unfold in a way that you can actually bend back up. So that's a common workflow where, again, I would have to hunt down the feature in the feature list, make the modification to that feature, and then, push out the new flat pattern. So again, it's never been an ideal workflow for those that actually manufacture the sheet metal parts that need to do these kinds of things. Change the bend radius, maybe even define a bend order. Another thing that you can do here is you can see I have all of these bends, joint A, B, C, D, and so on, and I can right-click, move them up and down in the order. And this is particularly useful, again, if I come back 6 months from now and I don't remember how I made this. Oftentimes, we'll see, companies have, PDFs or documents that lay out the order that they bend parts, especially more complex parts. And you can actually specify that right inside of Onshape. Right click on one of these cells, move up and down, and this will actually reflect the order that you bent the part. Right? And so these are details that you've never really been able to specify or build into your CAD model in the past. These are normally details that have been stored elsewhere, created by manufacturing. There's always been a big disconnect between the two steps in the process. And the idea behind this is trying to build that into a single place, with the sheet metal flat view always available and the table always available. These are things that are really manufacturing focused. Questions: are there predefined sheet metal tables with stock material thickness or different materials? No. As of today, it's just punching in a thickness value. And of course, you can apply materials to these to get details like the weight and so on. But there's not a predefined list of, gauge thickness and so on, right? It's a process of punching in a thickness value. So I think the question for mild steels or all metals or specific to metals and a specific gauge list based on metal selection, no. Today you would need that gauge list to punch in the value for your thickness in the sheet metal model command. Question: can I make a new feature to another part during the sheet metal construction, or does it need to close the sheet metal part? Can I make a new feature to another part during the sheet metal construction, or before it needs to close? You could create additional features after that initial sheet metal part creation, right? So in this case, you can see these three flanges. I'm not sure I totally understand the question, forgive me. So can I make a new feature to another part during the sheet metal construction or before it needs to close the sheet metal part? You can add additional features to your sheet metal parts after you accept that initial sheet metal feature. I hope that makes sense. I hope that I understand the question. Forgive me if I'm not. Can you emboss or louver on a sheet metal part? The answer is yes, but there's no automated tools to do that today. You would literally create a feature for that. I know there's an embossed foot command, but as of today, if you're creating these louvers and things like that, you would finish the sheet metal model. That's an important step in the process, and then create the louver and subtract it from your sheet metal part, or as you would normal CAD modeling. Does sheet metal support variable driven features? Sure. I'm not aware of any limitations to variables whatsoever. Well, in the part studio, not in the assembly. The assembly would be a different story. But yeah, I don't think there's any limitations to where you can punch in a variable today. Yeah. So I haven't personally tried it, so forgive me, but I'm 90% certain it should work just fine. Metal selection is there. Yes, you can specify the material if that's the question. How do you make or cut holes? You just create a circle, or if you want a hole, just create a circle, extrude remove. Can you model curved or rolled sheet metal with flat patterns? Yes. In fact, we just added that a few weeks ago. So if you tried using Onshape sheet metal, a month ago, 2 months ago, we did not have the ability to unfold rolled sheet metal parts. We do now have that ability. So just keep that in mind if you are working with those rolled sheet metal parts. All right, so what I'd like to do next, I've discussed the sheet metal table, the flat view. As I mentioned before, as you make a change in any one of these, it's going to update instantly in the other two. So you never have to worry about going back and forth or being out of date, or not knowing if the flat pattern is going to cause an issue. You can see it update live. Now, one of the other benefits of Onshape in general is the ability to design multiple parts in a single part studio. So this is a different technique than sheet metal, but it allows you to build multiple sheet metal parts together. And that's a really critical element to sheet metal design, because oftentimes you're designing sheet metal parts that are related to one another in enclosure scenarios and so on. And so in those scenarios, you would really want to design multiple parts in the same space rather than going between different tabs. And in Onshape you can. So if I want to create a second sheet metal part in this design, I can select the Start Sheet Metal Model command, just as I did before, go right back to this command, right? And I can choose what do I want to do. In this case, I want to thicken a few faces. As I mentioned before, you can convert a solid, or in this case, I can just click a few faces and thicken them. Right. So here I'm just selecting faces, clicking on my edges that are bins between the faces, and it's taking those faces I select, offsetting them with my sheet metal thickness, and creating bins to join them. So now I have a second sheet metal part, right, in this part studio. Right? It's still driven from that one, solid volume that we started with. So I could hit the green, check OK, and now I have my second sheet metal part. And you can see sheet metal model 2, and you can have as many sheet metal models as you'd like within your part studio. Can we use PIMs or other standard manufacturer libraries? If you import them into a model, absolutely. You can import them into an assembly and insert them as such. A lot of users will just create a document of PIM hardware. There's also an app in the App Store where I believe PIM hardware is available. Trace parts or cadenas. When can we unfold conical-like parts, like a funnel or cone? Question. Let us know. Use the feedback tool and let us know. I know that's a different functionality than something like a rolled cylinder. Can you use sheet metal to design deep drawn parts? And then no. If by deep drawn parts I mean deep drawn, sheet metal parts that you then need to see the flat pattern of, and the answer is no. This is intended primarily around press brake style design. Although we are adding more capability, very quickly, but I would say today it's largely geared around that, with the exception of the rolled functionality we just announced. But deep drawn designs where you need a flat, no. Now I will say there is in the App Store an app that will allow you to flatten just about anything. You forgive me on the name, but in the App Store, I know there are a number of different apps available to do this, and it's worth checking out if that's the kind of design you do. If you cut a hole through an angled face, does it cut at the right angle to the face? If you cut a hole through the angled face, it's going to cut a hole normal to the direction that you specify. So if you create it at an angle, well, I would need to test that. Let me test that later. Does the sheet metal tool allow for back cutting required for tight exterior radii? You can create a manual cut of any type that you'd like. Yeah, so I can take any Extrude Remove feature. I'm just going to create a random shape here, so forgive me. But I can create any kind of just random, rectangle, for instance. In fact, let's just do a rectangle. Right. And so I can take, something like this simple rectangle and just extrude remove, no differently than I would if this were a solid part. So just realize that you have the same extrude remove. If all you need to do is cut a hole through the part, I can grab extrude remove just as I would if this were a solid, block. And you can see if I jump into my flat here, there's my extrude remove in the flat. Right. All right, so that is creating a sheet metal part using the thicken command. I mentioned it earlier. All you need to do is just select faces. So I'm selecting a series of faces, collect the edges between those faces, and you will have bins between them. Right now, the question will come up: well, if you design multiple parts together, how do you see the different flat patterns? And you can see them by selecting the different sheet metal model features at the top. So if you have multiple sheet metal parts in your part studio, like I do now, you will see an option at the top to choose between the different ones. And you can just choose between the different sheet metal models in the feature to see the different flat patterns that you would like. So that's the second technique. So we discussed converting a solid. We discussed thickening faces, where we just select faces and it thickens them to create a sheet metal part. Now, I mentioned before, you can also, do things like sketch and open profile. And I think there are a lot of users out there, especially if you've come from, older CAD systems, that are familiar with this workflow. So I do want to show it. I'm just going to really quickly sketch out some very basic geometry here. So forgive me. Bear with me for just a moment while I mock this up real quickly. And so what I'm doing here, and the key is I'm sketching an open contour. All right, so this is an open profile that I've sketched, and we will sketch some constraints in here with the construction line, right? And let's make sure we have some symmetry, right? All right. So now let's add a few dimensions. Let's say 1.7, and let's take this out and add a few dimensions here. All right. So what I'm trying to do is just add essentially a platform for this, power supply. And what I want to do is use our extrude functionality to accomplish this. Right? So let's just say 7. Of course, we need a fully defined sketch. You got to follow proper technique. And so what we're trying to do here is extrude this open profile to create a part that unfolds, right? This is the third technique that we have for creating a sheet metal model. So I'll select the sheet metal model command. Again, I'm always going right back into that sheet metal model command. And I choose, in this case, the extrude option. So I showed you earlier the convert option, now the thicken option, and we can choose extrude. And I can choose just pieces of the sketch, or I can choose the entire sketch from the feature list if I choose to. Right, and then I can define my end type, set a depth no different than a normal extrude feature, and specify again thickness, bend radius, K factor, all those default settings that I want to establish. Right, and so now I have a third sheet metal part that was created just using an open contour. Right, an open profile. So that is a technique I know a lot of users out there are familiar with, and it's a technique that is very easy to do in Onshape. So again, those are the 3 ways that we have. Just to recap, we have convert a solid, thicken a face, and extrude an open profile, as we've done just now. Now, for time's sake, we're not going to go through necessarily every single sheet metal feature, but I did want to stress again those 3 critical ways that we have to get started with your sheet metal design. All right, so a few questions that I've missed. In flat mode, will it calculate footprint sizes? Yes. So and it will accommodate for K factor in the flat as well. That's a question I get asked often, but of course, when you punch in a K factor, it will accommodate for that K factor in the flat pattern so that you get the appropriate, stretch compensation for the bended part. So that's why, of course, you're punching in that K factor. Modifying the original volume updates sheet metal parts. Yes. And that's one of the benefits of this kind of master model technique is that initial solid block drives a number of parts, potentially. But yes, if you change the initial block, the sheet metal parts will update because they're driven by it. There's a parametric relationship between the two. Came in light, will we get a recording? Yes, everyone that registers for our webinars will get a recording. Question, back cutting is a machining process in the sheet metal part where a saw cut is made on the back surface. You bend at that cut so that your bend radius is tight and does not follow for sharp corners. I don't think we're going to have a specific operation for back cutting. I'm sure you could create the shape using our normal commands, but there's no back cut specific operation or feature in Onshape. Can we add weld grind callouts in the part studio? Can we add weld grind callouts? No. You can in the drawing, but not in the part studio. No annotations whatsoever in the part studio. So balloons or any of those types of things. That's all reserved today for the drawing. Can you use the developer API for Onshape to create or modify sheet metal parts for automation? I don't see why not. Yeah. In this case, if you look at this example, the entire thing was driven by that initial block, and it's very easy for me to edit that initial block and update sheet metal parts accordingly. And it's really how it'd be built. But the developer API does allow you to access and change values. Variables is an example. So if I design that block controlled by variables, I could manipulate it via API and spit out things. There's a lot of things in the API. Forgive me, I'm not an expert in every API call, but I do know that there's quite a few things that interact with sheet metal and variables too. Does sheet metal have the ability to create hinges for doors? I don't see why not. The hinge I'm picturing, forgive me, is just a flat plate with a tube welded to it, essentially. So I don't see why not. In fact, I think there are even public models of hinges out there. You might do a search for that. Could you please read clearly the questions for everyone to be able to get the answers to me? I'm sorry. I'm trying to go through them very quickly just for time's sake, so forgive me. The button finished sheet metal model, what is used for? Okay, so great question. Great segue into the next topic. So let's get into it. Now, the finish sheet metal model, the question is, what is that for? Right? There's a button here for finish sheet metal model. What would you use that for? And the answer is you may never need this button. If you don't, add the type of features that are necessary, you may never need this command. The question came up earlier, what if we wanted to add louvers? What if we wanted to add embossed features? What if we wanted to weld in gussets? What if we want to do these, weld in PIM studs into our sheet metal parts? I want to model an actual PIM stud right there in the sheet metal part. Well, remember, the rule of sheet metal is it has to be able to unfold, it has to be uniform thickness, and so on. Again, just keep in mind, when you do this, you're, creating a sheet metal part that can unfold. But there are certain things that can't unfold. Examples would be those welded in PIM fasteners or those, embossed feet. And those you would do after the sheet metal part is, cut and bent, right? And those would be considered finished sheet metal features. And so if you need to, add PIM studs, if you need to add gussets, if you need to add louvers, if you need to add those types of things to your sheet metal part, you will need to finish the sheet metal model, right? And it's a very simple thing to do. I click Finish Sheet Metal Model. I select the sheet metal part that I want to finish, right? So in this case, this Finish Sheet Metal part, I can do anything that I want to now. I can extrude boss just like a normal, extruded boss, right? So if we go in and hide, I can sketch on this face and create a standoff, for instance, just using these edges, just as an example. But my key point to make here is at this point, now that I've finished the sheet metal feature, right? Finish the sheet metal model, this sheet metal part can add any kind of feature that I want to it. Extrudes, those welded in features that you may want, all those types of things can now be done to it, right? And they could not in the past. And again, this is those types of operations that you would typically do, after a part is cut, right? And the reason I stress that, let's just create a quick extrude just to kind of prove the point here, right? Let's say up to face and just use the back of this piece here. And I can choose add and merge with the sheet metal model, right? So this step, the ability, let's hide the other parts here. Now I've merged just a normal extrude feature with a sheet metal part, right? Now, if I did not use finished sheet metal, I could not have done that. I would have gotten an error when I tried to merge this with this, because, as a rule, sheet metal parts have to be able to unfold. And what you'll notice, if I go to the flat, let's choose sheet metal model 1, you do not see those extrude features. Anything added after the sheet metal model is finished is not visible in the flat. Right. So again, a key thing to stress: think of those things that you would do after a part is cut. The bend operation, the press operations where you're doing louvers and embossed feet, or any kind of things that you may weld in afterwards. Those kinds of things are typically what I would do after I finish the sheet metal model. And you may not, need that. You may never do these kinds of sheet metal operations, but if you do, make sure to use Finish Sheet Metal Model. And again, all you need to do is select Finish Sheet Metal Model and click on the sheet metal part that you want to finish. Right? And then from that point forward, you can do anything to it as if it were a normal sheet metal model. Does it not cut the holes for laser cutting? Well, I did not cut anything. That was an extrude feature. I would need to create a separate extrude cut feature. Yeah, but you would need to do that in a normal, even if this were just a regular solid part, I would need to create a separate cut. But absolutely, you could go in and create an Extrude Remove feature, and all of that will be visible. Another question I get asked often is, well, if I finish sheet metal, how do I go back and make changes to the flat pattern? And the answer is it's just a feature in your feature list. So I roll up above it, and now I'm back into the mode where this is a sheet metal model, and I could do anything that I want to it, right? And anything that I do to it will update in the flat, right? Because I'm doing it before the finished sheet metal model feature in the feature list. So think of that start and end as a moment in time in that feature list, right? So if you need to make changes, just roll up above that point, and then you can roll back down when you're done, and everything will rebuild accordingly. So that's a simple intro into the finished sheet metal model feature. It's really intended for those kind of post-processing operations to sheet metal, but very common in those kinds of scenarios, and a tool you will need quite often. Question: are there features like tabs, jogs, miter flanges, or should we just create them using sketches and extrudes? You can automatically, select flanges and they will miter. So there is a flange feature. There is a tab feature. There is not a jog feature today, but you can create jogs with things like flanges in some scenarios. I know that the jog is a very specific command in some situations as well. So there is not a specific jog feature today, but there is ability to do this with other commands. Now, sketches and extrusions are a way to start a sheet metal model and also create cuts. You can essentially cut a sheet metal part using the normal extrude remove, and it's not limited to that. You can also do things like Boolean subtract sheet metal parts and other removal. You can remove geometry from sheet metal parts. You just can't merge extrudes and things with it until it's finished. I hope I made that clear. But that's the key reason that you have finished sheet metal. Can we save cutouts in the library to reuse them? There's not a automated way to do this. You can use in context and a library of parts to do this. What I would recommend checking out if you're at all interested in writing code is FeatureScript. You can build a library or a custom feature. That's what it's for. But there's no way to establish a library of established cuts or things like that today. Can you add a fold to a flat face? Sure. With the flange question, can you add a fold to a flat face? Yes, with the flange feature. And that was one I showed just a moment ago. Forgive me if I'm misunderstanding that question, but yes, we have a flange feature where you select an edge and it will give you that. Another thing to stress, notice I've selected a sheet metal feature, in this case flange, and I cannot select an edge of this sheet metal part, and that's because it's finished. Right? So if I wanted to do that, I would need to roll up above finished sheet metal, and then I could select something like a flange and left click the edge. Question: is that a him? Isn't it? No. We do have flange, no specific him. All right, so adding after the face has been formed somewhere on the face. I understand. So the question, adding after the face has been formed somewhere on the face. I believe the command you're referring to we would refer to as tab, where you would sketch like a closed profile that you want to attach to a flat face. Yes. I believe the command you're referring to is the tab, what we refer to as the tab command in Onshape. All right, so I want to leave the last few minutes open for questions. I see there are quite a few questions that have popped up, so I want to leave that opportunity for you to ask any questions in the final few minutes here. I do have one or two final things that I wanted to mention before we wrap things up. I just want to reiterate our advantage. Our approach to Onshape is different. You do have the ability to see the folded model, the flat model, and a table view of everything, and it all updates simultaneously. So if you're experimenting with your sheet metal parts and you want to see the flat pattern update live, Onshape is the only kind of tool that will allow you to do that. Otherwise, you're going back and forth, and it always led to this kind of trial and error approach. The other thing that I always like to mention is, manufacturing info can be built into the Onshape document, and that's something's really unique. You can build information like, what's the bend order that this part is bent? Is this a rip or a bend? Is this a specific bend radius that's different than the rest? You can see all of that in a table, and you can even edit it in the table. And again, if you edit the table, the folded, the flat, all update simultaneously. And the big thing that I would stress is in Onshape, there's not this back and forth between folded and flat, leading to that kind of trial and error approach to sheet metal design. So those are just a few of the advantages I like to mention. I am going to stick around and answer any questions that you have. So, please feel free to ask any questions that you'd like. I will stick around and answer them. One last thing that I had, if you're interested in learning more, I would definitely recommend checking out the Onshape Learning Center. Learn.onshape.com. There's self-paced training. If you want to teach yourself, there's a self-paced kind of walk at your own pace training. And we also have more instructor-led training, more hands-on style of training, and technical briefings available on the Onshape Learning Center. The technical briefings are great resources that discuss certain topics and how to do those things in Onshape. So valuable resources, great resources if you're just getting started, and I definitely recommend checking them out. So learn.onshape.com. So again, thank you everyone for joining. I am going to stick around and answer any questions that you have, so please feel free. But that's what I had. Thank you and have a good day.